Hi everyone, this is Mrs. Snobeck. Today we are going to start Unit 8, and Unit 8 will be all about perimeters and areas of polygons or two-dimensional figures. And today we're going to focus on parallelograms and triangles. So think back to Geometry A when you studied parallelograms. Remember, a parallelogram is a quadrilateral that has two pairs of parallel sides. So for instance, the top and the bottom are parallel, and the left and the right sides are parallel. If you have two pairs of parallel sides, it is a parallelogram. In this parallelogram, I'm going to call one side the base. So I'll say this down here is the base. Then this dotted line that comes down and is perpendicular to that can be called the height. The base and the height of a parallelogram have to meet at 90 degrees. They have to be perpendicular. So if we wanted to find the area of this shape, this parallelogram, the formula is base times height. B stands for base, H stands for height. Now I want you to think about one more thing. Think about a rectangle. So a rectangle is a quadrilateral that has four right angles. Would this also be considered a parallelogram? Does it have two pairs of parallel sides? Yes, it does. Also think about a square. A square has four right corners and four congruent sides. Would that also be a parallelogram? Would it have two pairs of parallel sides? Yes, it would. And so both of these will use that same formula as well. The rectangle and the square, if you needed to find the area of those, you would just do base times height. So base times height, base times height. So let's start with number 1A. Let's find the perimeter and the area of this parallelogram. Now, perimeter is the distance around the outside. And one of the things we know is opposite sides are parallel in a parallelogram, but also opposite sides are congruent. So this side down here would also be 21. This side over here would also be 17. So to find the perimeter, we're just going to add 21 plus 17 plus 21 plus 17, add up the four sides, and that ends up being 76 centimeters. That's the distance around the perimeter of the parallelogram. Now to find the area, remember, it's going to be base times height. So in this case, I can see the base is 21. It's this distance down here. But the height, we do not know. It would be that red dotted line. So to find the height, we're going to have to do a little Pythagorean theorem. And so we're going to do height squared plus 8 squared equals 17 squared. We're going to use this little triangle over here on the right, and we're going to do the Pythagorean theorem. So 8 squared is 64, 17 squared is 289. Subtract your 64 and you're left with h squared equals 225. And then we don't want h squared, we want just regular h, so we take the square root and we get 15. So 15 is your height. So to find the area, it's going to be 21 times 15, base times height. This comes out to be 315. And do you remember how to label something that has an area? It's in centimeters squared. So it's 315 centimeters squared. Let me explain why the label is squared. So imagine I divide this into 21 different pieces up here. That's approximately 21 different pieces. And then remember how it's 15 units high? Imagine I divide it into 15 units this way. You can see I'm off a little bit, but you get the idea. Guess how many little squares are inside of there? If you're guessing there are 315 squares that fill up this parallelogram, you are correct. You are correct. It's actually 315 squares that are each 1 centimeter by 1 centimeter that would fill this up. And if you're thinking about the edges where it's slanted here, you might end up with some triangles. But if you take two of the triangles and put them together, you're going to end up with a square. So that's where the centimeter squared come from. It's actually that many squares that cover the object. Okay, so let's try one more time. Let's get the perimeter. Remember, this is a parallelogram. Opposite sides are congruent. So this side is 6, this side is 10. So we're just going to add 6 plus 10 plus 6 plus 10 to get our distance around the outside of the object, the perimeter. And that adds up to 32 inches. And now we're going to find the area. Now this is a little confusing. You have to think about what's the base and what's the height. I like to think of this as the base, and it is 10, and then 5 is the height. So it's going to be base times height, or 10 times 5. That is 50 inches squared. Cool. Go ahead and try number 1C on your own. See if you can find the perimeter and the area, and then unpause the video and check to see if your answers are correct. So if you did the perimeter correctly, you should have gotten 96 feet. You had to do Pythagorean theorem to find this slanted side right here, and it turns out that that is 25. Now, one kind of tricky thing is the area. Remember, for area, it's going to be base times height. The base is the 23. So this 23 is your base. The height has to be perpendicular to the base. So imagine taking this 24 and sliding it over. This height would also be 24. So the base is 23, the height is 24. When you multiply those together, you get 552 feet squared. All right, are you ready for a blast from the past? This one says, find the area of the parallelogram using special right triangles. I'm going to cross that out. That's been so long, we might have forgotten about that. I'm going to say using SOHCAHTOA. Let's see if we can remember how to use SOHCAHTOA. So it says, find the area. It's a parallelogram, so it's going to be base times height. Do we know the base? Yes, the base is 12. Do we know the height? No, we do not know the height. It is a parallelogram though, and so this 9 over here on the right, we can transfer it over here, and this would also be 9. Now you can see this would have to be a right angle, and we have a 45, 45, 90 triangle. And so we can think about SOHCAHTOA. Here's your angle that's not 90. 9 would be the hypotenuse. H would be opposite of our angle. If you think about opposite and hypotenuse, O and H, that goes with SO. S stands for sine. So we could go sine of 45 equals opposite over hypotenuse. To solve this, you're going to multiply both sides by 9. So we're going to go times 9 on each side. These will cancel out. And then you're going to type in your calculator 9 sine 45. And you probably get 6.36. Go ahead and pause the video and try that and see if you get 6.36. So to find the area, base times height, it's going to be 12 times 6.36, which in our case is approximately 76 point, I think I get 37, depending on when you round. If you wait until the very end to round, that's the best. If you can just leave that number in your calculator and then not round it to the end. Let's try another one. So find the area of the parallelogram using special right triangles. Instead of special right triangles, let's just use SOHCAHTOA. It's probably more fresh in your brain than special right triangles. So here, do we know this is a parallelogram? We do. It says it in the directions. So it's going to be base times height to get the area. The base, I can see, is 32. You can see up here, that's 32. So that would be the same down here. They're both considered bases. But we need to find the height. The height would be this pink dotted line. So to do that, I'm going to look at the angle that they give me. This would be a 90-degree corner. We never use the 90, but we are going to use this red triangle right here. So here's our angle, the 30 degrees. The 12 is opposite of that angle. The H, the height of this parallelogram, that's actually the adjacent side. So you're looking for A and O. It's part of TOA. So we're going to go tangent of 30 equals opposite over adjacent, 12 over h. Multiply both sides by h, whatever's on the bottom of that fraction, right? And then divide both sides by tangent 30. So we have the height is 12 divided by tangent 30, which in this case should come out to be about 20.78 for your height. So we have our base, we have our height. Let's find the area. So it should be 32 times 20.78. This comes out to be 665.11 meters squared. Before we move on, I want to take a minute or so and I want to see how many of these conversions you remember. So please pause the video and fill in as many blanks as you can. So check it out. 1 yard is the same as 3 feet. 1 foot is the same as 12 inches. Hopefully you got those. 1 meter is 100 centimeters. And 1 centimeter is 10 millimeters. But look at this bottom part of the chart. Now we're dealing with square yards and square feet. So think about if you have 1 yard by 1 yard, but in each yard there are 3 feet. If we divide that into sections where there's like 1, 2, 3 feet by 1, 2, 3 feet, it actually is 9 square feet. So 1 square yard is 9 square feet. 1 square foot, if this is 1 foot by 1 foot, it's also going to be 12 inches by 12 inches, which is 144 square inches in 1 square foot. 1 square meter is going to be 100 times 100, so it's going to be 10,000 square centimeters. And 1 square centimeter is going to be 10 by 10, so 100 square meters. Now, for me, it's a lot easier to do these top conversions than it is the bottom conversions. And so when you're doing word problems and you see that your units are not the same, you might have to do some conversions. And my advice is always convert at the beginning of the problem. So here we go. You plan to restore an antique tabletop that is in the shape of a parallelogram. I always like to draw a picture, so here it is. If one set of parallel sides is each 3 feet long, so here's one set of the parallel sides, they are 3 feet long each, and the distance between them is 1.5 feet. So this height, or this distance, is 1.5 feet. How many square inches will you be refinishing? Notice they gave our measurements in feet, but they want to know how many square inches we'll be refinishing. So convert at the start. 3 feet, if you multiply by 12, 3 times 12 is actually 36 inches. So our parallelogram, instead of being 3 feet long, I would use 36 inches long. And then the height, 1.5 feet, well, times 12 is 18. And so this height in here is actually 18 inches. So now we can find the area of that antique tabletop in square inches. Remember, if it's a parallelogram, we're going to do base times height. Our base is 36. Our height is 18. And if we multiply 36 times 18, we get 648 inches squared. All right, moving on. Now we're going to talk about finding areas of triangles. The formula for area of a triangle, think about it. Can you remember what it is? It's basically base times height divide by 2. Some people think of it as 1/2 base times height. That's fine as well. I tend to do the top one, base times height, divide by 2. Again, the base and the height have to be perpendicular. So they have to meet at 90 degrees. Let's go ahead and go to the next problem. So find the perimeter and the area of each triangle. When they talk about each triangle, they're talking about the shaded triangle, okay? So we're talking about the blue triangle. Now to get the perimeter around that blue triangle, I can see one side is 19, I can see one side is 41, but I don't have that third side. I need to find it. And what I'm actually going to do is I'm going to use this triangle with the 27 and the 30, because that's a right triangle. I can do Pythagorean theorem. So 27 squared plus 30 squared equals c squared. And when I do that Pythagorean theorem, I get 729 plus 900 equals c squared, which is 1629. And if we take the square root of that, it's not a very nice number. It's about 40.36 is c. So on our picture, this distance right here is 40.36, this right there. Okay, but now we can find the perimeter of the blue triangle. It's going to be 19 plus 41 plus 40.36. You add up the three sides around the triangle. And those add up to about 100.36, and it would be inches. It's the distance around the outside. Now area, we talked about area is going to be base times height divided by 2. So here's the trick. What is the base of the shaded triangle? If you're saying 19, you are correct. The base is 19. What is the height of the shaded triangle? This is odd, but it's actually the 30. If you imagine sliding that over, the height between the top and the bottom is 30. So we're going to do 19 times 30 divide by 2. And that should come out to be 285 inches squared. Great, let's try the next one. We need to find the perimeter and area of the triangle. Sorry about that typo. So we're talking about the shaded triangle. Again, it's always going to be the shaded triangle, even if they don't say that. So we need to find two missing lengths. Let's start with this one over here. So I think we can do Pythagorean theorem. We can do 6 squared plus x squared equals 13 squared and figure out that height, basically, of the triangle. 6 squared is 36, 13 squared is 169. Subtract your 36, and you're left with x squared equals 133. Then we don't want x squared, we want plain old x, so we take the square root, and x turns out to be about 11.5. So this distance is 11.5. Now we can do the Pythagorean theorem a second time, and we will now try to find this side. So we're going to use this blue triangle to do that. We're going to do 11.5 squared plus 29 squared equals c squared, or whatever you want to call that third side. Go ahead and calculate this and then check to see if your answer is right. All right, if you got 31.2 for that third side, you are correct, 31.2. Now we can find the perimeter. So the perimeter of the shaded triangle is going to be 11.5 plus 29 plus 31.2. And when you add all of that up, you get 71.7 centimeters. To find the area of the triangle, remember, it's base times height divided by 2. What is the base of the shaded triangle? If you're thinking 29, you are correct. What is the height of the shaded triangle? If you're thinking 11.5, you are correct. Remember, they have to be perpendicular to each other. So to find the area of the triangle, we're going to do 29 times 11.5 divide by 2. And that should come out to be 166.75 centimeters squared. I love word problems. You need to buy enough boards to make the frame of a triangular sandbox shown and enough sand to fill it. Uh-oh, you're in charge of building a sandbox for your little cousin, and you have to get the boards, and then you have to get the sand, and you have to build it. So you need some supplies. If one board is 3 feet long and one bag of sand fills 9 square feet of the sandbox, how many boards and bags do you need? Well, boards, aren't the boards going to go around the outside? So the boards are going to basically be your perimeter. Okay, so let's think about what is the perimeter of the shaded triangle. So to get your perimeter, it's going to be, add up all the sides, so 12 plus 7.5 plus 16. You do not need to include the 9. That's not part of the shaded triangle. When you add all of those up, you get 35.5 feet. Now, each board is 3 feet long, according to this word problem. So if each board is 3 feet long, we have to figure out how many we need. So I would take 35.5 and divide by 3. I end up with 11.83. Can I go to the lumber yard and get 11.83 boards? Or do you think I might have to go and get about 12 boards? 12 boards is the number of boards you need. Now we're going to fill this thing. We're going to fill it with sand. And it says each bag of sand will fill 9 square feet of the box. And so I think when I see square feet, we're going to be talking about area. So the area for a triangle is base times height divided by 2. What is the base of our shaded triangle? If you said 12, you are correct. What is the height of our shaded triangle? It's actually the 9. Remember, it has to be perpendicular. So if I took this 9 and I slid it over right in here, that would be the height of the triangle. So here we go. We're going to do 12 times 9 divided by 2, which ends up being 54 square inches. Now each bag of sand fills 54 square feet. And each bag of sand fills 9 square feet. So you're going to take 54 and divide by 9. You need 6 bags of sand. 12 boards, 6 bags of sand. Okay, we're getting close to the end here, but we're going to do a couple working backwards problems. In this case, they're saying you have a parallelogram and you know the area, but you do not know the height. So I always start by writing down my formula. Since it's a parallelogram, it's going to be area is base times height. Plug in what you know. Do you know the area? Yes, it is 148. Do you know the base? Yes, it is 8. Do you know the height? No, they have an x over there. But look, we can solve this for x. Divide both sides by 8. 148 divided by 8. If you type it in your calculator, I believe you get 18.5, and it would be meters. So the height of this thing would be 18.5 meters. Is this drawn to scale? Not even close, right? It doesn't even look at all like our answer. That happens a lot in geometry. Number 7. This is a triangle, and I notice they give us the area of the triangle is 357 square inches. So I see some clues here. I know we're dealing with a triangle, and I know we're given the area. So I'm thinking base times height divided by 2 is going to be our formula that we're going to use because we have a triangle. Fill in what you know. Work backwards. Do we know the A? Yes, it's 357. Do we know the B? Yes, the base of the triangle is 34. Do we know the H? Not really. We'll call it X because that's what they call it. And then you have to include the divide by 2 because that's part of the formula. Now, there's a couple ways you could do this. You could change 34 divided by 2 into 17. Or I think a lot of you are used to doing this where you just cancel out the 2's. That's fine also. It really doesn't matter to me which way you do it. If you do it this way, 357 times 2, I think is 714. And then you would have to divide by 34. And when you do that, you get 21 equals X, and it would be 21 inches. Cool. One left. Last one. The base of a parallelogram is twice its height. Okay, let's just try to draw that. It's going to be a parallelogram where the base is twice the height. So if I was going to try to draw it somewhat proportionally, maybe it would look like this. Okay, if the area of the parallelogram is 72 square feet, find the base and the height. Well, we don't know the base or the height. This is kind of strange, but we do know the base is twice the height. So let's call the height H. That means this down here would be 2H because it has to be twice as much as the height. So keywords, area, parallelogram. We have a formula for that. Area equals base times height. 72 is the area, so 72 goes in for the A. Do we know the base? Nope, but we're calling it 2H. And the height we don't know either, but we're calling it H. Let's see if we can simplify this. 72 can stay by itself for now, but H times H is actually H squared. Then we can divide by 2. So we get 36 equals H squared because these 2's cancel out. And then we can take the square root and H equals 6. And it looks like we're dealing with feet. So the height is 6 feet. Now we also have to find the base, but just take your 6 and plug it in down here for the base. The base is 2 times 6, or in other words, 12 feet. Cool. Great, that wraps up Unit 8, Lesson 1. So now will you guys please try the practice? If you get stuck, let me know, and have a great day.